Assalamualaikum and good afternoon, good evening, or good morning to our lovely madam, Madam Razima binti Osman. So we from Group B, which is we are going to present about the differentiation in engineering mathematics 2, DBM 20023.
Hello, madam. My name is Differentiation. The content of this presentation is to meet the theme, and we will introduce the differentiation and the application of the differentiation, and also the example question. Last but not least, the conclusion.
As you can see, madam, it will be nice and good for me to introduce myself and my group members before we start our presenting. So my name is Muhammad Rizwan bin Junid and my matrix number is 07DKM22F2009, and as you can see on this slide, this is my fellow group members. So and the matrix number.
Hello, madam. I'm going to present the introduction of differentiation. Differentiation in mathematics is the process of finding derivative or rate of change of a function. We need to differentiate when the rate of change is not constant. The derivative of a function denoted as f prime x or dy dx tell us how the function's output changes as its input varies. Differentiation is an essential tool in various fields, including physics, engineering, economics, and the science, where understanding rates of change and instantaneous values are crucial. These are several techniques and rules for finding derivatives, such as the power rule, product rule, quotient rule, and the chain rule. Differentiations plays a vital role in optimizing function, solving differentiation equation, and providing insight into the behavior of function and the graphs.
Good morning or good evening to Madam Rizwan. My name is Simpson Stewart. My matrix number is DKM228 2006. First of all, thank you to my friends, Aaron, from last night. So I'm going to explain the application of differentiations. So differentiation can be used uh, to calculate the stationary point. So stationary point are point on a graph where the gradient is zero. The stationary point can be any of these, which is maximum, minimum, or the point of inflections. Just like what I say on the last slide, differentiation can be used to determine the stationary point, whether to search for maximum, the minimum, or the inflection point. But before we start, we need to apply the second order of derivative. Based on the picture given, the maximum point, the gradient is positive to the left of the maximum and negative to the right of the maximum. And for the minimum point, the gradient is negative to the left of the minimum and positive to the right of the maximum. And for the point of inflection, the gradient change from positive to zero back to positive or negative to zero and then back again to negative.
Hello, madam. I'm Jack Chong, and sorry, I don't know when is madam going to watch this, so I'm just going to say good morning, madam. I'm going to explain the example question, which is the question two. So this is an example question for our group for this presentation. For this question, we need to explain the solution to find the minimum, maximum, or inflection point for this function. Then we need to sketch the curved line of the graph for the function.
So this is the solution how to solve the question that have been given. So overall we got 6 steps. The step one is find the value of x. So the question that have been given is y equal to 4x power of 3 plus 3x power of 2 minus 6x. The first step is you have to do is the most important thing is differentiate. So dy over dx equal to 12x power of 2 plus 6s minus 6. This is the equation that have you found after you differentiate. Then, as you can see, this equation is similar to the quadratic equation. Then, by using calculator, go to mod eqn to degree 2, then just put a a value is 12, then b value is 6, then c value is negative 6, then you will find the value of x1 and x2, which is 1 over 2 and negative 1. Then after find the value of x, we proceed to our next step. Next step is step 2, which is we need to find the value of y. So as you can see, the the first equation is 4x power of 3 plus 3x power of 2 equal to 6x. Then by substitute x is equal to 1 over 2 and x equal to negative 1 into y equation, then you will get the answer of y1 and y2. And that's the step that we need to know how to find the value of x and value of y.
So I'm going to explain for the step 3 and step 4. So after we manage to find point x and point y, we going to get the stationary point. So our first stationary point is 1 over 2 and negative 7 over 4. For the second point is negative 1 and 5. After that, for step 4, we're going to determine the nature, which is we're going to dy dx. So we're going to change the x for 1 over 2. So when x is 1 over 2, just like in the given 24 in the bracket 1 over 2 plus 6. So we're going to get 18. So 18 is bigger than 0, so it's going to be our minimum point. And then for the second x, we're going to change it to negative 1. So 24 in bracket negative 1 plus 6, we're going to get negative 18. So negative 18 is smaller than 0, so it's going to be our maximum point.
I'm going to explain the solution of the question 2, which is step 5 and step 6. As we can see, the step 5 is to draw a table. I made this table with 6 columns and 2 rows. And the table must consist of value of x and y. So we calculated the maximum and the minimum point from the previous slide, which is the maximum point is negative 1 and 5, and for the minimum point is 0.5 and negative 1.75. After that, we write it into the table, and then we need to find the logic range, or the midpoint of negative 1 and 0.5, because this can make the graph more accurate when we plot the graphs and sketch the graph. So the best way to find the perfect midpoint is add 0.75 into negative 1, so I get negative 0.25. Same thing for the negative 0.25, we add 0.75 to get the 0.5. So this is the perfect midpoint between negative 1 and 0.5. And we repeat the same step for the second column and the last column of value x. After we got the value of x, we substitute the value of x into the original equation given to get the value y. After that, we can proceed to step 6, which is sketch the graph. As we can see, there are 5 points that I mark on the graph. For the first point, when the x is negative 1.75, the y will be same, which is negative 1.75 also. For the second point, when the x is negative 1, the y will be 5. And the third point, when the x is negative 0.25, the y will be 1.625. For the fourth point, when the x is 0.5, the y will be negative 1.75. For the last point, the y when the x is negative 1.25, the y will be 5. After we mark all the point, we should connect all the point to show a curved line. But this graph is not complete yet, but I will show them on the next slide. So this is the complete graph we got from the equation, and I made this graph from the GeoGebra apps. As we can see on the graph, there are 5 dots, and is the dots are exactly the same point that I marked on the graph from the previous slide. So we just need to connect all the point, and it will show a curved line, which is go up first and go down and go up again. So this is the complete graph for the equation. Thank you.
Hello, madam. It's me again, Ironishin. So, with the help of the previous slide and question, we can conclude that the differentiation involves the process of finding the rate at which a function changes as its input independent variable changes. In simpler terms, differentiation helps us understand how a function's output dependent variable respond to a small changes in its input. Differentiation is a powerful tool that plays a central role in understanding and modeling the behavior of functions in a wide range of fields. It allows us to quantify and predict how functions change and making it a fundamental concept in mathematics and science.
That's all for our presentation today, madam. I hope you enjoy our present or and our slide. Thank you, madam.